Hi everyone. In our last video, we created a smart contract, deployed it and tested on the Remix IDE. And this video, we are going to learn about what this smart contract do and what are the basics of Solidity that's used in this smart contract. First of all, I'm going to get rid of this left section so that we can just stay with our contract. And here, this is our contract. Before talking about what this smart contract do, let me tell you a little bit about smart contracts. So smart contracts are like our backend code in Web 2. But instead of running on centralized machines and servers like Google Cloud, Amazon Web Services, Microsoft Azure, it's running on decentralized platforms, chains like Ethereum, BNB, Chiliz, and many others. So basically, we are writing programs that can be run by any machine in that blockchain. And in general, Solidity is created for Ethereum. It's compiled using Ethereum virtual machine, but many other blockchains also use Ethereum virtual machine like BNB or Chiliz chain. So we can write Solidity smart contract and we can deploy it in many networks that are compatible with EVM, which is again Ethereum virtual machine. Now, let's look at our simple smart contract. And this smart contract is a basic counter like we experimented in the last lesson. And here we have just three functionalities. We can either increment the value of this counter, we can decrement the value, or we can get the current value of this counter. Now, let's look at how we implemented this counter. First, we are going to start writing our contract with the contract keyword here. For the time being, you don't have to worry about what's happening here on top. So here we started with this contract keyword, and here as you can see the name is example, but we can make this name any name we want. So I can also make this counter, but let's keep it for example for the time being. Now that I have my contract, my logic will be inside of this contract. First, I want to tell a method that I'm using. In general, I see contracts in three parts. The first part is the data part, where we are going to create the necessary data that will be used in this smart contract. The next part are the execute functions, and these functions are the ones which is going to change something on the blockchain. So we are updating data here. Since we are updating data on the blockchain, they are going to require some gas fee. And this gas fee is the little amount of token that we pay for transactions. And the third part is the query functions. Query functions are the ones that we retrieve data from the blockchain. We don't change any data on the blockchain, hence they are free. We don't pay any gas fee for the query functions. So I think about smart contracts in three parts. So let's first look at the data part, which is going to include this section. We have an address owner, and this address type is specific to Solidity, and this indicates Ethereum address or blockchain address. And we called the name owner here, so the owner will be the one who is obviously the owner of the contract. And next, I created a struct. So creating structs is like other programming languages, and these are custom data types that we are going to use a lot during our smart contract development. So you can think these structs as the objects if you are coming from JavaScript or any other object-oriented programming language. So we have this counter struct here, and inside this counter struct, we will have different fields. It's like if we have a human struct, let's say, then we have different fields, like we have the hand, we have the eyes, we have the mouth. So the totality is the human, but we have different fields. So here the totality is the counter, and the different fields are the number and the description. And this number is going to indicate the current status of the counter, because it can be 1, 2, 3, it goes up, it goes down. So this is the part that where we are actually going to keep the number. And we have a separate part, which is a description. And this description is going to tell us what this counter is for. So what's the goal of this counter? As you can see, I have a string type for the description. So it's again like any other programming language. But here I have a type called uint instead of integer. So what does uint mean? So this uint basically means that unsigned integer, which is positive numbers including 0. So we can say the natural numbers. So we cannot have a number like -2, -1, minus something, but we can have the numbers which is either 0 or above. And it's used a lot in blockchain development since in general we are working with 0 or positive numbers. So whenever you see uint, just think of a number which is either 0 or positive. Next, we have our counter instance. Here we said that, okay, we are going to have a structure called counter which has fields called number and description, but we didn't create any instance, so we just defined human, but we just didn't create any human. So here, that's what we are doing. We created our counter, which is called counter with the lower c, and then we are going to initialize it on our constructor. But for the time being, let's keep it like this. Next, as you can see, we have a modifier. So modifier is a concept that is created by Solidity, and it's actually a big helper for us. So in modifier, we are defining a condition, and if this condition is true, we are going to go with our function code. But if this condition is false, then we are not going to pursue our function code. Our name of this modifier is only owner, and it's used a lot in Solidity development. That means that only the owner of this contract can actually access this function, call this function. And we are going to say require inside of this modifier, and we are going to indicate the condition here. And the condition is that the message.sender equals to the owner. This owner comes from the address above as we defined, and this message.sender is the one who sent the transaction. If you remember, we had different addresses here in our last example, and for this address, message.sender will be the address starting with 5b3 and ending with EDDC4. But if this address is sending the transaction, then the message.sender will be 5c6 and ending with 21678. So we are getting the message.sender, and we are saying equal to owner. And if this condition is true, then it's going to go to this line, and this line means that just continue with the function. But if this condition is false, then we are going to return an error, and we are creating the error here after this semicolon. And for this situation, our error is only the owner can increment or decrement the counter. And again, we are creating these modifiers to use with functions. On their own, they don't make any sense, but when we use them with functions, that will make sense, and we are going to talk about it just in a little bit. Next, we have our constructor, and constructor is a special kind of function in Solidity which runs just once when we deploy our contract. If you remember, we said that we need to indicate the initial value and the description of this contract before we deploy it. And the reason for that is our constructor needs an initial value and a description. And we initialize our contract giving these parameters to our constructor, since constructor just runs once, and that's during the deployment process. So here we have two parameters for our constructor, initial value, so that we can start our counter with that value, and we have the string description. So basically, we are getting these fields, and after getting these fields, we are saying owner is message.sender, so we are setting the owner to the address which is deploying this contract, because as we can remember, message.sender is the one who is actually sending this transaction. And after setting this owner to the message.sender, then we are going to say counter equals new counter. So we are creating structs with this syntax. We are giving the struct name, and inside the parentheses, we are giving the values so that we can have an instance. And the values that we need to give is the number and the description. We are getting these values from this function's parameters, which are the initial value and the description, and we are passing these values. So at the end of this constructor, we will have an owner which is equals to the message.sender, the address that deployed our contract, and we are going to have a counter that is initialized with the initial value that we indicated here with 0, and the description which we indicated with the example here. And also, you may notice that we have a keyword called memory. So what does this memory do is actually a little bit important. In Solidity, we have two types of variables. We can either store this variable inside a blockchain, so the value is not lost between function calls. But we may also have values that we need during our execution process, but we don't need them to be stored on the blockchain. And this memory indicates that we are just going to store them for the time being, and we are not going to store it on the blockchain because we are just getting this description and giving this description so that we can have a counter, but we are going to store this counter on the blockchain. And every value we created here are going to be stored on the blockchain, so we don't need to indicate that we want them to store on the blockchain. This owner, this counter struct, and our counter instance will be all stored on the blockchain. But if we want to indicate that we want them to store on the blockchain in functions like this, instead of memory, we can say storage, and this means that we want to store this variable permanently on the blockchain. But for our function, we need to say this is just a memory. Now, this was the data part. So the second part that we are going to talk is the execution functions, which are these two functions. So we create the function with the keyword function, and then we give the function name. We have the parentheses here. If this function gets any parameter, we indicate them here like we did on our constructor. But our increment counter doesn't take any parameters, so we move on with this external keyword. In Solidity, we have these keywords for the function, which we can call function types, and we have 4 different ones. The first one is, as you can see, the external. As the name suggests, this means that we cannot call this function inside from our construct or from any construct that inherits it. We can only call this function from outside of this construct. And since we are going to just use this function from the front end, then we don't need to say this is anything other than the external, right? Again, it means that we are just going to call this function from outside of the construct. And we can have internal, which is another option. And internal means that we are going to use this function inside this construct, and this function also can be called by any construct that inherits our construct. And the last two are public, which means that we can use this function in any way we want. We can call this from this construct from outside, so it's a function for everyone. And finally, we have private, which means that we can only call this function inside of this example construct. We can't even call this function from a construct that inherits this construct. So private is just for this construct, and external is, which is ours, means that we can call this outside of this contract. Next, we have the only owner modifier. If you remember, we said that we are going to make the check here, and if our condition passes, then we are going to go to this line, and this line means that continue to the function. Once we said only owner here, it's going to check if the message.sender equals to the owner. If that's the case, we are going to go on with this line, and this line means that continue to the function. And we are going to continue to the function, which is this line. And here we are incrementing the number from the counter by 1. To get the number from this counter struct, we are saying counter.number. If you wanted to get the description, we would say counter.description. And then we are saying plus equals, which means actually this counter.number. So instead of saying counter.number equals counter.number plus 1, we are basically saying plus equals, which is very widely used in different programming languages too. So with this function, we are incrementing our counter by 1. And with this function, as the name suggests, decrement counter, we are going to decrement our number from the counter by 1. And other than that, we have the same external and only owner keyword. Then we have a function, which is our third part of this construct, which is the query functions part. And this query function, again, is just retrieving data from the blockchain. Hence, we are not changing any data on the blockchain, and we don't need to pay any gas fee for this kind of function. So we are going to say get counter value for the name, And again, it's going to be an external function. As you can see, we are telling these are external functions because I'm not using increment counter function anywhere inside my contract. I'm just going to define it. And that's why I'm saying it's an external function. It's going to be called outside of this contract. Then again, we have this external here. And now we have also a new keyword called view. This view means that we are retrieving data from the blockchain. So we are accessing some data, but we are not changing any data. We are just getting some data, and this is called view. We also have a different kind of functions which are called pure. And pure means that we are not even retrieving any data from the blockchain, and we are not changing any data from the blockchain. So pure functions are just the functions that don't use any data from the contract code. And as you can see, when I said pure here, I get an error with this counter.name, and it says that function declared as pure, but this expression reads from the environment. So the pure means that we are not going to access any data from the blockchain, but we are accessing this counter from the blockchain. So it's not valid for this pure function. Hence, instead of pure, we are going to leave it as view. Then we have this returns, and in Solidity functions, we indicate the return type with this returns keyword. And inside the parentheses, we are going to give the name, the type name of the variable that we are going to return. Since we are going to return the number field of the counter, we are going to make this uint. Again, if you remember, it means that natural number. But if we wanted to return the description, we would have said a string, and we would say this is the description. But since we are returning the number, I'm just going to leave it as uint here. And now this is all of our function. Let's compile this again. And then we are going to look at our test once more. So this is from the last lesson, if you remember. Now I'm going to delete this deployed construct, and I'm going to create a new one. The initial value will be 10 this time, and the description will be something else than example. Let's say trial lesson, and then I'm going to say transact. And our owner will be this address with EDDC4. Since we are saying owner equals message.sender in our constructor, and in our constructor we send this transaction with this account, so our owner will be this account. To understand this, we can say, let's get our counter. As you can see, now we initialize it with 10 instead of 0, and it happens here with this initial value. Now I'm going to change my address to some other address, 35CB2. And here I'm going to try to increment the counter. Let's have a little bit more. As you can see, we had an error. Let's try this again. Let's try to increment again. As you can see here, what we have is an error, and it says that only the owner can increment or decrement the counter, which is defined by us in this modifier. What happened is that we tried to call this increment counter function. We tried to use this increment counter function with this address ending with 35CB2. Since we had the only owner modifier, it checked if the message.sender is equal to the owner. And since our owner was this account which we deployed our contract with, our owner was not equal to the message.sender. Hence, we got this error message, and our function didn't continue with this line, because if we hit this line, it means that just continue to the function. And if I change this again to this account, and I try to increment the counter, as you can see, I had no problem. If I check my counter, it's 11. If I decrement my counter and check it again, it's 10. So we can use these functions with the owner account, with the owner address, but we cannot use these functions if we don't have the owner address. But since we don't have the only owner modifier in this function, whichever address I choose, I will be able to use this function without any problems. And as you can see, I have still 100 Ether, so I didn't pay any gas fee. So these are the basics of Solidity, And that's how we created our construct. And you will have your construct under this section with the code commented, so you can look at it again for the reference. So for the time being, thank you very much, and I hope you will learn a lot in this tutorial.